Hi, and welcome back to Psychology with me, Mr. Snyder, and today we are going to discuss how psychologists use the scientific method for research and ethics in doing so. So, we're going to talk about the scientific method and how it's applied to psychology. We'll discuss various research methods. We'll talk about ways to improve the validity of the findings of research methods. We'll talk about ethical standards for research in psychology with humans, discuss the purpose of non-human animal research, why we use animals, and we'll also identify the ethical guidelines. So let's get started. So you guys know what the scientific method is. You've had it since elementary school. It's the system of gathering data so that bias and error in measurement are reduced. We want to be as unbiased as possible. The steps in the scientific method for psychology are to first of all formulate the question, which is talk about something interesting, something that interests you, and formulate the question you really want to discuss. You also want to formulate a hypothesis, which is the tentative explanation for the phenomenon that you're observing, and overcoming confirmation bias. This helps overcome confirmation bias by seeking out information that might contradict the bias. And confirmation bias is when you only look for information that is relevant to proving you right rather than what proves you wrong. Then you design an experiment to test the hypothesis. Then you draw conclusions. And if the measurements support your initial observations, you report that and you report your results. It's helping let others find out what you know. Outcome 2, your hypothesis is not validated and you need to go back to square one and think of another possible explanation. And lastly, whether or not you're right or wrong, you need to report your results, because the reporting or publishing your results helps others know what you find so that they can learn from your experiment, maybe do an experiment of their own. Now we're going to talk about different ways to observe and describe. So the describe and compare the various research methods. Naturalistic observation is watching animals in their normal environment, and that includes humans too. The advantage of which is it gives a realistic picture of behavior, but the disadvantages are if people know that they're being watched, then they have a tendency to behave differently, and that's called the observer effect. So it's the effect of the observer on the behavior. It's going to change it. And in order to kind of get away from this and make it more valid, we can do participant observation, which is when the observer becomes a participant in the group being observed, and that helps reduce the observer effect. Observer bias. This is why we need to keep these two straight, effect versus bias. The bias is the tendency of observers to see and only look for what they expect to see. They're only looking for what they expect to see. It's a type of confirmation bias. So a way to kind of levy this is to use blind observers. It's send other people into the situation and let them do the observing, because they don't know what the research question is. Also, having more than one observer can help with this as well. Laboratory is kind of the opposite of naturalistic. It's watching humans or animals in a laboratory setting. It allows for a great deal of control over the environment, which the naturalistic setting does not let you do. It also allows for the use of specialized equipment in observation. But the artificial situation may result in artificial behavior. Also, we can use a case study, and a case study is a study of one individual in great detail. You can see this picture here. This is the case study of Phineas Gage, who was a railroad worker in the 1800s who had a pipe go through his head. Okay, not something you can really replicate. He had a pipe go through his head and he lived, and his personality changed, so they studied what parts of his brains were injured and what effect those parts of the brain had on his behavior. The advantage is it also allows for a tremendous amount of detail in one person or one small group. It's the only way to get certain kinds of information. Like I said, we can't ethically replicate putting pipes through people's heads. It's also a good way to study rare conditions, but you cannot apply it to others for ethical reasons or logistical reasons. Surveys. I'm sure you filled out a survey here or there. When you want to know very personal things, you ask a series of questions about the topic under study. This can be conducted in-person interviews, also on the phone, the internet, or with a written questionnaire. You give the survey to a representative sample, and this is a statistical term, which means that it's a randomly selected sample of subjects from a larger population of subjects, but with the same general characteristics of the group. So if I wanted to survey Carroll High School, I would give it to a couple freshmen that were representative of the freshman class, same with sophomores, juniors, and seniors. I couldn't just give it to freshmen because that would not be representative of Carroll High School as a whole. The advantage is you can study those secret covert behaviors that people don't like to talk about. You can also gather data very easily from a large number of people. The disadvantages to a survey are that you have to ensure the representative sample is representative of the larger population, or else the results can't be transferred and they won't be meaningful. People are notoriously not accurate, and people also may be guilty of courtesy bias, which is giving a socially correct answer in order not to offend anyone. Disadvantages of surveys. Another one is that the wording of the survey questions and the order that they appear can affect the outcome of the survey. We'll talk more about that in class. This is why we use those critical thinking skills in psychology that we talked about in class. This critical scientific thinking can help sort out and solve these real world problems. It also can help evaluate claims that may actually be false. Finding relationships between the data that we produce. Relationships are called correlations. It's the measure of a relationship between two or more variables, and variables are anything that can change or vary. We're just going to kind of gloss over correlations now because we're going to talk about them more in depth in a little bit. But the measures of two variables that go into a mathematical formula and produce a correlational coefficient represented by R, which represents two things: the direction of the relationship, whether it's a positive or negative number, and the strength of the relationship, whether it's closer to +1 or closer to -1. So it's going to be somewhere between -1 is a very strong negative relationship between the two variables. One goes up, the other goes down. A closer to +1 is a very strong positive relationship where they both move in the same direction. And this is just what I said. I meant to go to this next one. And closer to 0 is 0.0. That would be absolutely no correlation between the two. We also just kind of talked about this, positives and negatives. Positive correlation, variables increase in the same direction. Negative correlation, as one increases, the other decreases. So the more you smoke, the less healthy you are. A positive correlation would be the more apples you eat, the more healthy you are. This does not prove that what the two variables are moving in the same direction, that one causes the other. There's a very funny website out there that shows very strong correlations between two random things, but positive correlations are basically one does not cause the other. And we say correlation does not prove causation. Apples do not make you healthier by themselves, but probably they have something to do in playing with that. Here are a screenshot you can take. Perfect positive correlation, perfect negative correlations, and then you have modest and negative and positive correlations, and then finally a scatter plot with no correlation. You just get random data everywhere. Now we get to the experiment. The only way to prove that one thing caused another is through an experiment. We hold all variables constant except for one, which we deliberately manipulate to see whether we get a corresponding change in behavior. And that allows the determination of cause and effect relationships. Correlations do not. The selection must be random. You must get a random selection of a sample from a certain population. That would be that representative sample we talked about. You also need to come up with operational definitions, and that's defining what a variable of interest is that allows it to be measured. So if we're talking about aggression, what actually constitutes aggression, and what would we be looking for in an experiment that would constitute aggression? Would it be hitting? Would it be, I don't know. We would have to come up with that together. This should be reviewed, the independent variable and dependent variable. The independent variable is the one that is manipulated by the experimenter. So everything else is held constant. You can see these kids fighting with swords here. Maybe the independent variable would be what is on the television. So is it a violent show or is it a non-violent show? The dependent variable is what we are measuring. So in this instance, it might be aggression. The groups, the subjects in an experiment who are subjected to the independent variable is called the experimental group. The control group is not exposed to the independent variable. And in order to control for confounding variables, which may be a variable that interferes with each other and the possible effects on some other variable of interest, maybe in an experiment with kids and aggression, it would be gender. Maybe girls are less aggressive naturally than boys. I don't know. It could be a confounding variable. But the point is to have two groups, an experimental group and a control group. The experimental group is the one that is exposed to the independent variable. The control group is not exposed to the independent variable, and they usually get no treatment or a treatment that could have no effect, and we call that a placebo. And it's important to be random and to even assign subjects to the experimental or the control groups randomly so that each subject has an equal chance of being in either group. This takes bias out of the picture, and it also allows for control of confounding variables. Random assignment. Each participant has an equal chance of being assigned to each condition. Experimental hazards. Let's talk about the placebo effects, which is the phenomenon in which the expectations of the participants in a study can influence their behavior. So a placebo effect, if you're getting a drug that could cure cancer, let's say, so to speak, and you're in the control group, they're going to give you a sugar pill as a placebo so that you still think you're taking something. But just the mere expectation that you are taking something that can help you with help cure your cancer can make you improve. The human body is an extraordinary thing, and it can do some very powerful things, some of which we're not even aware of most of the time. And then the experimenter effect. If the experimenter knows who is in which study, they can unintentionally influence the results of the study. And that's why we need to control for the experimenter effect with a double-blind study. A single-blind study is when the subjects do not know whether they are in the experimental or the control group, but the experimenter does. A double-blind is when the experimenter does not know which subjects are in experimental or control group. And if you want to be as unbiased as possible, you have to do a double-blind study. Let's move on from that to ethics and ethics in psychological research. You have institutional review boards at every university and psychological group who look over each other's proposed research study. So before you do a research study, you have to turn it into an IRB so that it will be overviewed for safety and ethical considerations for participants in the study. Other common ethical guidelines with working with humans, the rights and well-being of the participants' safety must be weighed against the study's value to science. If it's not going to hurt them, but it has a huge value to sciences, to gaining more psychological research, then we go ahead and do the experiment. Participants must be allowed to make an informed decision about whether or not they participate, so that's called informed consent. They need to know about the possible risks. Deception must be justified. If you're going to trick a person in a study so that they don't know what's going on or what you're actually looking at, you must justify it. Participants must be able to withdraw from the study at any time as well. Also, they must be, I think I mentioned, told of the risks of the study. After the experiment, they must also debrief participants, telling them what the true nature of the study was, and their data must remain confidential. If for any reason the study results in undesirable consequences for the participants, the researcher is responsible for detecting and removing or correcting those consequences. For animals, animal research takes place in not a lot of experiments, but sometimes it is necessary to draw conclusions with stuff we can never investigate ethically with human research. So a lot of that involves orphaning monkeys and taking people away from their mothers. We can never do that with humans. Some people could argue we can never do that with animals either, but it does help out to be able to do that with animals. Looking at the long-term effects of things becomes much easier since animals live shorter lives. Scientists also have a much greater control over animals than they would people. And after we do experiment with animals, we can then conduct a correlational study using people. Whenever we can deal with animals in research, we want to focus on exposing animals to unnecessary pain or suffering. And like I said, it's used in less than 1 in 10 experiments. So we don't use animals in a lot of experiments anyway. That's all I have for Module 2. Be sure to fill out your learning targets and come on back to class and we'll answer any questions you have. Bye-bye.